Hey you guys, in this video we are going to look at these last couple objectives from Chapter 5, Section 2. So in the last video we checked off writing a polynomial in factored form, solving for the zeros, writing a polynomial function from its zeros. So we marked off those three. The last two we're going to do, or the last two objectives that we have for this section, are I can find the multiplicity of a zero, and this actually should be I can graph a cubic function. So those two objectives, I can graph a cubic function and I can find the multiplicity of a zero, are the two objectives we are about to cover. Alright, so our first objective is determining the multiplicity of a zero. So multiplicity just covers, or just means that we have that zero multiple times. It lets us know how many times we have it. So, for example, it says the polynomial in factored form is, and it already has it factored for us. So to find the zeros, all we have to do is use the zero product property, which is fairly simple. So we'll say x plus 2, our first parenthesis here, set it equal to 0. Take the x minus 1, set it equal to 0. Take the x minus 3, set it equal to 0, and we have another x minus 3, so we'll set that equal to 0. So when we solve the first one, we'll subtract 2 to each side, so our first 0 will be negative 2. Our next 0, when we add 1 to each side, will be 1. The next one, when we add 3 to each side, will be 3, and our last one, when we add 3 to each side, will also be 3. So the zeros for this polynomial are, well, we have negative 2, and we only have that, if you look at all of our other zeros, we only have negative 2 one time. So its multiplicity is just once. We have x equals 1, so that's another 0. Again, we only have that one time, so it's a 0 of multiplicity 1. And then we have 3. And you see that it appears twice. We have it here, and we have it here. So this has a multiplicity of 2. So again, multiplicity, it just means that that 0 appears n amount of times as a factor. Alright, so I want you to try below. Here you have a polynomial. It's already in factored form. Notice this says x plus 5 squared. Up here, this could have been written as x minus 3 squared, but instead they just wrote it out twice. So keep that in mind. So I want you to go ahead and find the zeros for the polynomial and determine the multiplicity of each. So what does multiplicity tell us? Multiplicity tells us what the function is going to do at the point on the x-axis. Remember, where your graph crosses the x-axis, we can call that a 0, we call that a root, we call that an x-intercept, or we could call it a solution. So don't forget all of these words, 0, root, x-intercept, solution, they're all the same thing. So multiplicity tells us what our function, what our graph is going to do at the point on the x-axis. What our graph is going to do on the 0, at the root, on the x-intercept, at the solution. Alright, so if we have an even multiplicity, so the problem before we saw multiplicity of 1, well that was odd. Multiplicity of 2, that was even. So even multiplicity, our graph will bounce off of the points. And our graph will appear to look like a parabola, as far as there will be a turning point there. So notice right here we have a 0 at 0 actually. And notice that our graph went through this 0, but when it came up to the second 0 at 0, it bounces off of it. It just comes up, it touches it, and turns back around. So that 0 serves as a turning point. In odd multiplicity, our graph will go through the point. It will look like a line. And notice right here, this is a 0. So -2 is a 0, and it just goes straight through it. Also over here, we have 1, 2, 3, 4. 4 is a 0, and it goes straight through it. Just appears to be a line. But again, this one, it goes up to this 0, and it turns back around. So it just touches it and turns around. It doesn't go through it. It bounces right off of it. So even multiplicity is going to bounce off. Odd multiplicity, it'll go through. All right, our second objective for this video was to graph cubic functions. So before we talked about graphing cubic functions by just making an XY table. Some cubic functions, there is an easier way to go about graphing for some of them. And those are the ones that you can factor. So steps to graphing a cubic function other than making an XY table, a good way to do that would be to see, can you factor it? So step 1, find the factors and factor them. I guess that's a little redundant. I guess you could just say factor the polynomial. So in this example, again, f of x, that's the same thing as y, right? So we don't really care about that. We're looking at this right side, and we're just asking ourselves, can we factor it? First step in factoring always is GCF. So our GCF here is an x, and what's left over is x squared plus 4x plus 4. We have a trinomial, so I'm thinking first times last, that adds to be the middle. So what multiplies to be 4, that adds to be 4. And I come up with 2 and 2. So I have y equals x, because that was the GCF. I have 2 sets of parentheses. Since it's a simple trinomial, it's going to be x and x as the first term. And 2 was what I found, so a positive 2 and a positive 2. Now that I've factored, I'm going to determine my zeros and my multiplicity, if any. So, zeros, setting each of my factors equal to 0, I have x equals 0, I have x plus 2 equals 0, and I have x plus 2 equals 0. So solving for each one, the first one is solved, x equals 0. The second one, I get x equals -2. And the last one, I get x equals -2. So instead of writing that twice, right next to where I wrote x equals -2, I'm just going to write a comma and say multiplicity of 2. So now I know that 0, I'm going to have to bounce off of it. Versus this first 0, x equals 0, I'm going to go through. Now to know my general shape of this graph, I need to know my turning points and my end behavior. Well, this is in standard form, and if I go back to the original, this is my first term. So my lead coefficient is 1, and that's positive. And my degree is 3, which is odd. Positive and odd. Well, positive people bring you right up. And since it's odd, odd means opposite, so the left will be going down. I also need to determine my turning points, and since my degree is 3, then 3 minus 1 is 2. This is not a special case since there's another x in there, so I'm going to have 2 turning points. I'm going to say TP for short. Alright, so I know that my graph, I'm going to sketch it over here. I know my graph is going to look something like this, but I need to make sure that I go through this 0. So I'm going to put a point there, x equals 0. I'm I'm going to go through that one since it has a multiplicity of 1. But at -2, which is over here, I'm just going to bounce off of it. So I'm going to touch it, but I'm not going to go through it. So since I have to start down, my graph, I'm going to go up, I'm going to touch the 0, turn around, and then go back through this one. So there's my sketch. No, it's not beautiful, but my end behavior is like it should be. It's supposed to be down and up, so I have down and up. I'm supposed to have 2 turning points. I was going up, oh, I've turned around, I've gone down, and I've turned again, I'm going up, so I have my 2 turning points. And I'm supposed to go through 0, I'm going through 0, and bounce off -2. I'm bouncing off a -2. So here's my sketch of my cubic function. Alright, last thing for you to do, you try this problem over here. I hope you took good notes. I'll see you in class.